This is the second of the circuit videos, and in this one we're going to talk about a different kind of circuit called a parallel circuit. So if I were to, instead of lining up my resistors like I did for the series circuit in the previous video, if I stack all of my resistors in a line like this and wired them up so that I had multiple paths and I could go through any one resistor as I go around this circuit like this, I would have a parallel circuit. So a parallel circuit is one where there are multiple paths. So if I have my resistors R1, R2, R3, and maybe I have my 9-volt battery down here, 9 volts, I have different paths that I could go around this circuit. And so there's two things you need to remember about a parallel circuit that are really, really important to remember. And that's that the potential difference or the voltage across each of these branches, branch R1, branch R2, branch R3, is the same. Okay, so if this is 9 volts for the battery down here, I have 9 volts across each individual branch. The other thing that you need to know about a parallel circuit is that the current that is broken up and flows through each of these branches it adds to the sum of all currents entering the branch. Okay, so what do I mean by that? So if I were to come down here, I would have some current I total, and I would be entering this branch point here, and at that branch point the current would be split three ways. I'd have a current I1, I'd have a current I2, and I would have a current I3, like that. And so if I were to add up I1, I2, and I3, I1 plus I2 plus I3, I would get I total. Okay? And I can get a little more information out of this if I apply Ohm's law. Remember, Ohm's law is V is equal to IR. That's my Ohm's law. And so I'm going to substitute, I'm going to move my letters around in Ohm's law and have V over R is equal to I. I'm going to substitute V over R into this equation. So instead of having I, I'll have V over R. So V over R total is equal to V over R1 plus V over R2 plus V over R3. Okay, and remember I said before the potential difference is the same in all of these branch points, and so V is V is V is V, and because it's in all the terms I can cancel it out, and I can simplify this to R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, and now I have an equation where I can find the total resistance of all of these resistors in the circuit. Okay, so let's test it out. Let's test it out. So I'm going to come down here. So I'm just going to move my equation. So 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, and so I want to find R total for the circuit, so I'll go 1 over R total. I'm going to assign some numbers to my resistors. I'll say R1 is, we'll use the same numbers as we did in the previous video, 3 ohms, 6 ohms, and 9 ohms. Okay? And I'm doing this because you'll see there's a big difference between parallel and series circuits when you do this. So R1 was 1/3, or 3. R2 is 6. R3 is 9. Okay? Don't forget, when you add fractions, I've seen students do this a lot, you need to make sure that you find a common denominator. So 1 over R total, I'm going to use 18 as my common denominator. So 1 over R total is equal to 6 over 18 plus 3 over 18 plus 2 over 18, and that adds up to 11 over 18. Okay, but we're not done yet. So what we've found is that 1 over R total is equal to 11 over 18. We don't want to express our resistance as 1 over R total, and so I'm going to take the inverse of each of these in order to get an answer. So I took the inverse of both of those, so I get R total is equal to 18 over 11 ohms, or it's about 1.6 ohms. Okay, that's pretty good, and that wasn't so bad. But remember, I've seen students do this a lot. They forget to flip R total, and they get the answer wrong. Let's make some room. Now, what can we do with this information? So, what if next I wanted to find, so what if I wanted to answer the question, what is the current flowing into the branch point? Okay, so I want to find the current, I total, basically, that's flowing into these branches right here. And so I know that I can use Ohm's law for almost everything. So V is equal to IR. Trying to find current, so I'll solve for current. Okay. My voltage is 9 volts, because that's what the voltage of the battery is. And it's the same throughout because we're talking about a parallel circuit. And I found my resistance up here, 1.6 ohms, or 18 over 11 if you want to be really precise. And if you use 18 over 11 and not 1.6, you'll get a more precise number, 5.5 amps. So the current flowing into the branch points is 5.5 amps. What if I wanted to make it a little more interesting, and I wanted to find the current in each branch? Of this circuit. Okay, so we can do that too. Let me make some more room. Okay, so what is the current flowing into each branch? Well, remember, each current is going to be independent, and then they'll all sum up to what we found. The total current going into the circuit was 5.5 amps. All right, so what is the current flowing into each branch? I say our voltage is equal to IR for all of them. And I'm going to find I1 to start with. So I'm going to talk about current 1 and R1. And remember, voltage is the same for all of these because we're in parallel. Okay, so I'll move some letters around so I can solve for current. So V over R1 is equal to I1. I need to find V, and I need to find R1. So I can find I1. So V is equal to 9 volts, as it is everywhere in this circuit, so I'm always going to use 9. 9 volts. R1 is equal to 3 ohms. And so V is 9, R1 is 3, and I get a current of 3 amperes. What if I wanted to do R2? Let's do R2 really quick. V is equal to I2, R2. V over R2 is equal to I2. V, remember V is always 9 for parallel circuit. R2 is equal to 6. Okay, do our substitution. 9 volts divided by 6 ohms is equal to 1.5 amperes for R2. Last one, for V is equal to I3 R3. So we need to find V, which is 9 volts for all of them, and R3, which is, in this case, our last resistor, 9 ohms. So 9 volts. Oh, we need to move our letters around. V over R3 is equal to I3. So 9 volts divided by 9 ohms gives me 1 ampere. If I were to sum all these up, so I'm adding I total is equal to I1 plus I2 plus I3. I would find that 3 amps plus 1.5 amps plus 1 amp sum to 5.5 amps, which is I total, which is the very, very same amount of current we found entering the branch. So you've probably noticed by now the currents flowing through the parallel circuit are much, much higher, and we will discuss that in class. All right, that's it.